Welcome to Plutus IAS, and today we are covering the rock salt structure, the ionic crystal structure for your rock salt, which is also goes by the name of NaCl. So here, in case of NaCl, if we talk about, the crystal structure is formed by the anions. They are arranged in a FCC manner. For FCC manner, the coordination number is given by Z equals to 4, while Na plus are found in the octahedral voids formed by the Cl minus ions, in which we have Na plus on 12 edge centers and one at body center and at body center. So, and if you clearly see that Na plus will also have Z equals to 4. Z equals to 4. That, and this contribution can be achieved by, since we have 12 edges having each Na plus, and each edge is being shared between 4 different cubes at the same time, plus 1 at the body center which is not being shared, which gives you the total contribution equals to 4. Here we can see that the Cl minus and Z have exactly same contribution. So does that mean Na plus and Cl minus both can have some relation with one another? Well, exactly that's the case. So first we'll move for Cl minus. So here, if I make Cl minus ion on the F center, if they are forming the H center, these yellow ones are your, wait, for the regularity, let's take a circle, far better. So Cl minus here, okay, for our sake, let's make some F here at the faces. So now we can clearly see that every single Cl minus ion right here is occupying what? This one is occupying the faces of every single side of the cube. So now the only spaces that are left for the placing of, for my placing of sodium, the only places I have left, they are decreasing the size, it's changing the color to, how can I change its color to better? So here, if I take it and I place it at the edge center, which is right here, edge center here, edge here, and similarly to all other places. Now, if you clearly look at this picture, you can also see that, and one would be at the body center. Now, if you clearly look at this picture, it looks a lot like the case that Na plus is also forming FCC lattice. But the thing is, it is too crowded. So let's try to separate one thing from the another, and we can figure out how it is possible. So I make a copy out of it and I remove, let's remove the Cl minus so that we can understand. So we already know that Cl minus is forming the FCC lattice. How the Na plus is forming its FCC? So if I take it, you can see this is forming a cube. Similarly, one such right here, it is forming another cube at the base. Now let's join them. Now if you clearly see these particular atom which are on the outer edges, they are coming in the face of this. They are coming in the face of this particular unit cell that I have made. Now whatever is nahi, one then oh, 4 4 4, now the bases that are left, okay, that's correct. So we can clearly see it is forming its own FCC lattice. So if I copy this particular solid and repeat it multiple times, what I can see is that the entire lattice is being formed by such repetitive units. Now, at the same time, if I need to find which particular lattice is being formed by the FCC, you can see this particular is forming what? A base. A similar base will be formed by a molecule which is right here. Joining them, and you will find that here we are having atoms at the corner. So initially for the when the FCC lattice was being formed by the Cl minus ion, the Na plus atoms Na plus ion which were coming at the edges are now coming at the face center of the unit cell for FCC lattice formed by the Na plus ions, and this scenario will keep on rotating itself, and that's how we can say that both Na plus and Cl minus are forming their FCC lattice. Now the question arises how we can define the type of void that is being formed here. So for the type of void, what we can see, we can clearly see that if I take this lattice again right here, okay, so I already know that the Cl minus is present at the center of this. For the Cl minus, the Na plus were coming at the center, and for the Na plus, it is the Cl minus which is present at the center. So if you see here, right here, these four would be here, and one would be here, and one would be here. Okay. Let's say for the sake of ease, let's remove all of them. So one Na plus is coming at the very center of it. So if you see here that if I form a cube out of the four faces, this Na plus crystal is coming between a void which is being formed by the 6 Cl minus ions, which proves that this coordination number 6 is a proof that the Na plus is occupying the octahedral void which is being formed by the 6 Cl minus ion. And similarly, if you go by the case for Na plus, you will also find that the that the Cl minus is also occupying the octahedral void which is being formed by the Na plus ion. But for most cases in your exam, we will always refer that it is the Na plus ion which is present in the crystal. This analogy is being used just so that we can satisfy the radius ratio rule, because as per radius ratio rule, the size of the ions is being very different, okay, for most cases, but we will discuss that later in the class why radius ratio rule is just for the sake of understanding. It has not much of applicability, but in a very limited area of space. So I hope this crystal structure has now been clear to you. In case of any doubt, you can add it to the comment section, and I hope this visualization will help you in learning more about the crystal structures. So thank you for joining us, and we'll see you later.